This is question number 1, CPET 2021. It is given A. Clearly A is an infinite set, and you have to find out the supremum of the set A. So what is supremum? LUB. LUB is otherwisely called as supremum. So LUB, the full form of LUB is least upper bound. So upper bound, what are upper bounds? So you can see the definition of upper bound from your book. So here let's think about the set A. So what is an upper bound? What is an upper bound of the set A? I can say the number an upper bound is a number which is greater than or equal to all the elements of the set A. An upper bound is a number which is greater than or equal to each element of the set A. So for example, I can say 0.5 is an upper bound of the set A, 0.9 is an upper bound of this set A, 0.7 is an upper bound of the set A, 0.8 is an upper bound of the set A. You can check one is an upper bound of the set A, 2, 3, 4, 500, 1000, 1 lakh are upper bounds of the set A. You can know there are infinite number of upper bounds of this set A. So here our business is to find out the least upper bound. So that is supremum. Least upper bound is otherwisely called as a supremum. So if you'll observe this the pattern among the elements of the set A, you can know the what is the least upper bound of the set A. So please observe. So the first element is 0.2 and the second element is 0.22. The third element 0.222. Here 1 2 here this is 0.2 and here 0.22 and here it is 0. This is 0.2, this is 0.22, more 1 2 has been placed there, and here this is 0.22, this is 0.222, so more 1 2 has been placed there. This is 0.222 and this is 0.2222, so more 1 2 has been placed. So having observed the pattern among the elements of the set A, we can know the 0.2 to this is 0.22222 that is 0.2 where is an upper bound of the set A. Yes, it is the least upper bound. It is the least upper bound of the set A. We knew 0.22222 that is 0.2 bar is an upper bound of the set A, and it is the least upper bound of the set A. So this is the supremum of the set A. So but 0.2 bar is not there among the options. So the options are in fraction forms. So we have to convert this 0.2 bar into fraction. When we will convert this 0.2 bar or 0.2222 into fraction, we will get 2 by 9. You can check it. I have also explained here how this 0.2222 which is a non-terminating and recurring decimal number can be converted into p by q form where q is not equal to 0. How we will convert this into fraction. Decimal numbers are of two kinds. The first kind is uh, terminating decimal number and the second kind is non-terminating decimal number. And every terminating decimal number is a rational number. It means every non-terminating decimal number, every terminating decimal number is a rational number. So every terminating decimal number can be expressed into the form of p by q where q is not equal to 0. Then the case is coming of non-terminating decimal numbers. Non-terminating decimal numbers are of two kinds. First kind is non-terminating and recurring decimal number, and every non-terminating and recurring decimal number is a rational number. It means it can be expressed, every non-terminating and recurring decimal number can be expressed into the form of p by q where q is not equal to 0. And the next case, every non-terminating and non-recurring decimal numbers are irrational number. Every non-terminating and non-recurring decimal number is a irrational number, because 0.222222 dot 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 it is a non-terminating and recurring decimal number. We can express it into the form of p by q where q is not equal to 0. We can convert this into fraction. You can see class 9 NCRT book or class 9 ODI medium book or class 9 RD Sharma book, and there it is given how a non-terminating and recurring decimal number, how a non-terminating and recurring decimal number can be converted into p by q form where q is not equal to 0. So this is 0.222222 dot 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 dot. Here our business is to convert this into fraction, convert this into p by q form where q is not equal to 0. So to convert it into this form, we have to take x is equal to this. Then in the next step we will multiply 10 with both sides of the equation, and this is 10x and this is 10 into this, so it became 2.2222, and then 10x is equal to, we can write it 2 plus this, 2 plus this, and you can see we had taken x is equal to 0.2222. So we can substitute x here. We can place x instead of this, because we have taken x is equal to this, so it is 10x is equal to 2 plus x, and 10x is equal to 10x minus x is equal to 2, 9x is equal to 2, then x is equal to 2 by 9. So 2 by 9 is the answer. So 2 by 9, this is 2 by 9, so option B is true. Option B is true. Then we'll come to question number 2, and it is given in the question, in question number 2 it is given a limit n tends to infinity of this is equal to dash. So first we'll take y is equal to this, y is equal to this. So we can also write it to this 1 square plus 2 square plus 3 square plus n to the power and whole to the power 1 by n. We can also write it like that. So we took y is equal to this. So here our goal is to find out limit of y. Limit n tends to infinity y. If we can find out the limit of y, then that will be the answer. So to find out the limit of y, we have to solve it. So we have first we took logarithm of both sides. Logarithm, this is y and this is 1 square plus 2 square plus 3 square plus dot 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 plus n to the power n whole to the power 1 by n. We have to take logarithm of both sides. So this is log y is equal to log of this. So log y is equal to 1 by n will come to this place, and then we have to take limit of both sides. Limit n tends to infinity. We have to take limit of both sides, and this is we took limit n tends to infinity of this, and limit n tends to infinity of this. Then in the next step, limit n tends to infinity log y is equal to limit n tends to infinity. So this is 1 by n. We can also write whole divided by n, and log of 1 square plus 2 square plus 3 square plus dot 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 n to the power n. We can also write it, this is 1 square plus 2 square plus 3 square plus n to the power n. We can also write it n into n plus 1 into 2n plus 1 whole to the power 6. So it became log n into n plus 1 plus 2n plus 1 whole divided by 6, and this is n 1 by n, so it placed here whole divided by n. So when we are finding the limit of this, when we are finding out the limit of this, so this is infinity, so n into n plus 1 infinity, this is n plus 1, so the numerator, so log, this is log infinity, log infinity is equal to infinity, log infinity is equal to infinity, so the numerator become infinity, and this is n, so when we will place infinity on the place of n, so it will also be infinity, so it will be infinity by infinity form. So we have to apply L'Hospital rule to find out the limit of this. So here we will apply L'Hospital rule. So here the variable, here we have to take the derivative of the numerator with respect to n, and we have to take the denominator with respect to n. So limit n tends to infinity, so, limit n tends to infinity, this is log, uh, we can write it when we will multiply this 3, this n into n plus 1 to n plus 1, we can get 2n square plus 3n square plus n whole divided by 6 whole to the power n. We will find out derivative of this numerator with respect to n, and we will find the derivative of the denominator with respect to n. Then when we will find out the derivative of the numerator, that is log of this, so log of something is equal to log of x, derivative of log x is equal to 1 by x, so derivative of log this is equal to 1 by this, so when 1 by this, we can write it 6 by, we can write it 6 by this, this will be reciprocal, so 6 by this. Then we have to, according to chain rule, we have to find out the derivative of this. So what will be the derivative of this? 1 by 6 is the constant, so we can take 1 by 6 outside, so this is by 6, and we brought 1 by 6 outside, so we can place 6 like that, this is whole divided by 6, and this is 2n cube, we can write it 3n 6n, we can write it 2n cube 6n square, so 2n cube, 3 into 2 is equal to 6, then n to the power 3 minus 1, that is 2, so this is 6n square, and this is 6n, and this is 1. So and the derivative of this is 1, derivative of n with respect to n is 1, so when we will multiply this, when we will multiply this to 6 will be cancelled, then we will get limit n tends to infinity, 6n square plus 6n plus 1 divided by 2n square plus 2n cube plus 3n square plus n. So in the next step we will bring n cube as common, so when we are bringing n cube common from the numerator, so this is 6n square, so when we will bring n cube common from 6n square, when we will bring n cube from 6n square, it will be 6 by n, 6 by n, so it is 6n, when we will bring n cube common, it becomes 6 by n square, and it is 1, so it becomes 1 by n cube, and come to the denominator, when we will bring n cube common, it will be 2 by n cube, sorry, when we'll bring n cube common from 2n cube, it will become 2, when we'll bring common n cube from we will bring n cube common from this denominator, and we will bring n cube common from n cube from 2, it will be 2, and when we'll bring n cube from 3n square, it will be 3 by n, and when we'll bring n cube from n, it will be 1 by n square, so this is, and n cube will be cancelled, so here we have to find out the limit of this. So so this is 6 by infinity is equal to 0, 6 by this is also infinity is equal to 0, and this is 1 by infinity is equal to 0, and 2 is the constant, 3 by infinity is 0, 1 by infinity is 0, so 0 by 2, 0 by something is equal to 0, and so it was log limit n tends to infinity log y. So it is limit n tends to infinity log y is equal to 0. Then limit n tends to have to find the value of limit n tends to infinity y. Limit n tends to infinity y. So limit n tends to infinity y is equal to this was 0 and this is 0. This became e to the power 0. So e to the power 0 is equal to 1. So option B is true. So there is also, and I have also mentioned an alternative process of the same question, of the solution of the same question. So you can see it. So limit n tends to infinity 1 square plus 2 square plus 3 square plus n to the power 1 by n, n to the power n whole to the power 1 by n. So we can write 1 square plus 2 square plus 3 square plus n to the power n is equal to n into n plus 1 into 2n plus 1 whole divided by 6 whole to the power 1 by n. So then in the next step we'll do, so this is 1 by n is the power of the, we can write it n to the power 1 by n into n plus 1 to the power 1 by n into n plus 2n plus 1 to the 1 by n divided by 6 by 1 by n. So 1 by n came for this, so it is n to the power 1 by n, and 1 by n came for this, so it became n plus 1 to the power 1 by n. So and similarly 1 by n, similarly this is 2n plus 1 to the power 1 by n, and this is 6 6 to the power 1 by n. So in the next step we'll do this is limit n tends to infinity, limit n tends to infinity n to the power 1 by n, and n to the power 1 by n into this is n plus 1 to the power 1 by n. We can write it when we will bring n common from this, when we will bring n common from this, so it will be n into this is 1 and this is 1 by n into this is 1, this is 1 by n, so n into 1 plus 1 by n, this is whole divided by 1 by n, and this is whole divided by 1 by n. So similarly this is 2n plus 1, we will bring 2n common from 2n plus 1. So when we are bringing common 2n from this, we are getting this is 2n, and this is 1 and this is 1 by 2n, this is 1 by n, so whole to the power 1 by n, and divided by 6 to the power 1 by n. So in the next step this is n to the power 1 by n, and this is 1 by n into 1 plus n to the power 1 by n. So 1 by n will come from come for this, and 1 by n will come for this. So this is n to the power 1 by n into 1 plus 1 plus n to the power 1 by n. Similarly, this is 2n to the power 1 by n into 1 plus 2n by 2n, 1 plus 1 by 2n to the power 1 by n. So we will arrange it. This is n into n to the power 1 by n. This is also n to the power 1 by n, and we will bring this 2n to the power 1 by n here. And this is 1 plus 1 plus 1 by n to the power 1 by, okay. You can see this is 1 plus 1 by n to the power 1 by n. So we can write it. We can write it 1 plus 1 by n to the power n whole to the power 1 by n square. Because when we multiply n with n square, we are going to get 1 by n. When we are multiplying n with 1 by n square, we are getting 1 by n. So it is 1 by n. So we can write we can write this, we can write 1 plus 1 by n whole to the power 1 by n as 1 plus 1 by n whole to the power n whole to the power 1 by n square. So similarly this is 1 plus 1 by 2n whole to the power n. So whole to the power 1 by n, we can write it 1 plus 1 by 2n whole to the power 2n whole to the power 1 by 2n square. Because when we are multiplying 2n with 1 by 2n square, we are getting 1 by n. So we can write this as this. So, and this is 6 by 1 plus 6 by 6 to the power 1 by n. Then we have to find out limit of this. So we know that limit of this n to the power. You can, so this is n to the power 1 by n, and this is n to the power 1 by n, and 2n to the power 1 by n. This we can write it 2 to the power 1 by n into n to the power 1 by n. So this is 2 to the power n by 1 by n into n to the power 1 by n. 2 to the power n by n into so this is 2 to the power 1 by n into n to the power 1 by n. So when we will find out the limit, so limit of this will be 1. Limit, we know limit of n to the power 1 by n is equal to 1. So limit of this will be 1, limit of this will be 1, uh, limit of this will also be 1, because 2 to the power 1 by infinity, 1 by infinity is equal to 0, 2 to the power 0 is equal to 1. So this is 1, this is 1, limit of this 1, limit of this 1, limit of this 1, limit of this also 1. So you can write so it is 1 into 1 into 1 into 1. Then when we will find out the limit, when we'll find out the limit of this, when we'll find out the limit of this 1 plus 1 by n whole to the power n, that is e. So it will be e to the power 1 by n square, e to the power 1 by n square, that is infinity. So e to the power infinity is equal to e to the power 1 by infinity is equal to e to the power 0. So it is e to the power 0. This is also 1 plus 1 by 2n whole to the power 2n, 1 plus 1 by 2n whole to the power 2n. Limit of this will be e, and this is 0, 1 by infinity is equal to 0. So this is e to the power 0. So it is 1 into 1 into 1 into 1 into e to the power 0. This is also 1, this is also 1. So 1 by 1 is equal to 1. So option B is true. So 1 is the answer here. With the fast process, so answer was 1, option B is true. So by this alternative process, answer is 1, option B is true. So answer of this question is here option B will be true. Then we'll go to the next question, that is question number 3. So question number 3. So question number 3 is, let n be a sequence of real numbers. Suppose that limit of n to the power 1 by n, that is q. Limit of n to the power 1 by, limit n tends to infinity, n to the power 1 by n is equal to q. I will call it limit of n to the power 1 by n. So which of the following is true? The first option. So to solve this, we have to use we will use Cauchy's nth root test to solve this problem. Remember, Cauchy's nth root test is yes, Cauchy's nth root test tells about the series convergent or the series divergent. When the limit of, when limit of limit of n to the power 1 is equal to 1, then the test fail. So so please see, this is Cauchy's root test, and the you can see these two things. First is Cauchy's nth root test. Second is a necessary condition of a series to be convergent. If a series, that is summation n, is convergent, then we can say limit n tends to infinity, n is equal to 0. Limit of sequence, limit of the sequence n, limit of n will be equal to 0. So let's see option A. So what does option A tell? So option A, if q is lesser than 1, it is given if q is lesser than 1, then limit of n is greater than 0. So if q is greater than, if q is lesser than 1, please see, q is less, q, what is q? Limit of n to the power 1 by n. Q is limit of n to the power 1 by n. So it is option A is saying that if if of n to the power 1 by n is lesser than 1, then limit of an is greater than 0. You can see if limit of an to the power 1 by n is lesser than 1, the series is convergent. This series is convergent. If the series is convergent, then limit of an is equal to 0. But here it is given limit of n is greater than 0. So you can say this option is not true. So then we will go to option B. Option B. So what does option B say? It is said when q is greater than 1, q, what is q? Limit of n to the power 1 by n. Limit of n to the power 1 by n. Yes, when limit of n to the power 1 by n, when limit of, that is, this is limit of n to the power 1 by n is greater than 1, clearly the series is divergent. The series summation n diverges. So when q is greater than 1, it is clear that the series diverges. It is clear that the series diverges. We can use a theorem. We can use a theorem here to actually B option is true. So to prove B option, to know B option B is true, we can use a theorem. I am showing the theorem to you, so you can see this theorem. So this is un to the power 1 by n, un to the power 1 by n. If limit of un to the power 1 by n, this is L. Limit of un to the power 1 by n, that is L. When L is greater than 1, please see carefully. When L is greater than 1, that is limit of un to the power 1 by n is greater than 1, then we can say limit of the sequence un is infinity. So you can see this theorem, you can use this theorem here. So when uh, this is a limit, this is q, the limit of n to the power 1 by n is greater than 1, you can see limit, this is limit of un to the power 1 by n. So limit of, this is limit of un to the power 1 by n. When limit of un to the power 1 by n is greater than 1, then limit of un is equal to infinity. So here the limit of un, limit of n to the power 1 by n, which is greater than 1. So limit of the sequence, that is n, is equal to infinity. So you can apply, you can use this theorem to know that option B is true. So option B is true. You can you can use this theorem to know it. So I have also mentioned this theorem here. Here you can see. Here I have also this theorem is also there in this document. So it is q, I have taken the limit q. So we will we could know that option B is true. Then we will go to option C. Option C. So option C is not true, and option D is also not true. So let's see option C. So it is given when q is lesser than 1. Q means limit of n to the power 1 by n. When limit of n to the power 1 by n is lesser than 1, the series according to Cauchy's root test, the series n will be the summation n will be divergent. Sorry, will be convergent. We can see when q is lesser than 1, the series is convergent. When the series is convergent, so limit of n will be 0. But here in option C, it is limit of n is lesser than 0. So option C is not true. And let's see option D. So option D, it is given if q is greater than 1, then limit n tends to infinity, mod of n is greater than infinity. So due to greater than infinity, the option D is unsuitable. Option D is unsuitable. So option D is not true. So we can conclude option B is the true option. So option B is the answer. Option B is true here. And we'll go to question number. Then we'll come to question number 4. So it is limit n tends to infinity this to the power n equal to dash. So options are there. So we will take limit of this is equal to this. This is the sequence. So we will take even the sequence is equal to this. So if we can find out limit of even, then we can get the answer. So even is equal to this. When this n will come to this side, so we can write even to the power 1 by n is equal to root n minus 1. Then we will find out the limit of this. So limit of this is equal to limit of this. So limit of this will be infinity. Limit of this will be infinity. So limit of the sequence to the power 1 by n. Here limit of un to the power 1 by n, which is infinity. It is greater than 1. It is greater than 1. You can see the same theorem. So when a limit of un to the power 1, when limit of un to the power, that is L, limit of un to the power 1 by n, or limit of the sequence to the power 1 by n is greater than 1, then limit of the sequence un is equal to infinity. You can apply this theorem to solve this, to know the answer of this question. So you can see, so limit of un to the power 1 by n, which is infinity, that is infinity, and it is greater, of course infinity is greater than 1, or plus infinity is greater than 1. So as a limit of un to the power 1 by n, which is infinity, and infinity is greater than 1, we can say limit of un, limit of un is equal to infinity. Limit of the sequence un, according to this theorem, limit of the sequence un, sorry, limit of the sequence un, limit of the sequence un is equal to infinity. As limit of un to the power 1 by n, limit of the sequence to the power 1 by n, limit of un to the power 1 by n is greater than 1. So we can say limit of un is equal to infinity. So we can say limit of un, what is un here? We had taken un is equal to root 10 minus 1 whole to the power n. So root 10 minus 1 whole to the power n, that is infinity. So you can say limit of root 10 minus n whole to the power n, that is infinity. So option D is true, answer is infinity. Option D. This is option D is true. Then we'll come to question number, this is 5. Question number 5. So so here there is a sequence, that is n plus 1 whole square, n plus 1 whole square divided by 2 square. So n belongs to the set of natural number, and we have to find out the supremum. We will find out the supremum of that sequence. So least upper bound is otherwisely called as supremum. So to find out the supremum, first, so this is the first, when we will substitute n on the 1 on the place of n, we will get a 4 by 4, and this is 2 plus 1, that is, this is 3 square is equal to 9 by 4, 3 plus 1, and this is 3 plus 1, 4 to the power 4 to the power 2 is equal to 16 to the 16 by 4, 25 by 4, 36 by 4, 49 by 4, and this is 64 by 4. And when we will convert so this is the decimal form. This is 4 by 4, it is 1, and this is 9 by 4. The decimal form of 9 by 4, this is 2.25, and this is 16 by 4. The decimal form is 4. This is 16 by 4 just 16, so it is 4, and 25 by 4. It is when the decimal form of 25 by 4 is 6 by 6.25, and so on. So if you'll observe this, the elements of the set A, if you'll observe the elements of the, if you'll see the elements of the set A, uh, you can know where it is going towards. This is 1, this is 2, 2.25, this is 4, and this is 6.25, and this is 12.25, and 16 and 25. It is moving with increasing order, and by observing uh, the elements of the set S, while observing the elements of the set S, we can see it is impossible to find out the least upper bound of S. It is impossible because you can say the sequence is moving towards infinity, plus infinity. The sequence is moving towards plus infinity. Uh, we can say it is impossible to find out the least upper bound of the set S, and the set is on a bounded above, and the set is unbounded above, and there is the set has no upper bound. uh, the set is unbounded above, so we can say the supremum or the least upper bound of the set is undefined. So the least upper bound of the set is plus infinity. And we can also see here that this is a sequence, and if you find out the limit of the sequence, that is infinity. If the limit of a sequence is infinity, then we can say the supremum, we, the set is unbounded above, and the supremum or the LUB, it is undefined. So the least upper bound of the set is undefined. This is plus infinity. But infinity is not there among the options. So this is as the list upper bound is 2. This is 1 by 2. This is 1 by 4. Option, the first option is 2, and second is 1 by 2. Third is 9 by 4. Second is 25 by 16. So there is a mistake in this question. So it is also, I have also mentioned there. So there is a mistake in the question number 5 of CPET 2021. You can check it. So thank you so much.